Howdy. This is an overview for 2.3. What we're going to be talking about here is front-end loading, or loading the hopper or the schedule of a rig running. Managing a project and using GIS to help manage a project. We've obviously looked at wells and well bores, but we're going to also now look at as drilled. So as we plan to do these wells, what were the outcomes from these wells? Let's go through and look at this project of this Matador Resource Company. This goes to a good detail of looking at their operations and their investments into trying to explore both the oil production and natural gas areas. And then the estimated revenues that they plan to get out of these will kind of dictate how they're going to go about drilling the wells, predicting where they're at and where they should go for. Here we can see where their acreages are held. Here south of San Antonio, going up through into Karnes County, DeWitt, Gonzales, down McMullen, Webb, so forth and so on. You can see the areas of coverages, and they have several areas here that they have quite a heavy holdings in oil and gas revenues that they plan to explore. Drilling down deeper into those, we look at the land shapes and the land patterns that they need to get into these areas in the basins that they're going to go for. Now, if they're in the Haynesville Shale, we'll have the Haynesville Shale spacing and requirements that we need to look at in trying to drill these wells for a Haynesville Shale type scenario. So here we see some of their Haynesville Shale in their Eagleford. Again, they're going to have to go through the Eagleford things. They want to try to reduce their drilling times. They use rotary steerable tools, so they need to have precise positioning, knowing where they're trying to hit their targets and go for. And they want to improve the fracture and the flow of fluids and try to maintain that information and use the best that they can. And a lot of that has to do with their drilling times and how well they drill their wells. So here we see the measured depth to the amount of time that it takes to drill some of the wells. And as they go deeper, you can imagine they might go out to further times to drill. Here's the first 4 wells that they got, and you can see they got better as they were going along. So the last 4, they've gotten really good at the amount of time that it takes to drill these wells. And you can pick up the time, but how clean does the wells get drilled is very important. Then you look at the total costs that they had for each wells that they were drilling. Normalized costs, they're reducing some of their costs by they have carryover costs or things that they can use from well to well in that cost aspect. Now, in terms of the directional drilling, what does it bring to them as we look at the depths that they're drilling into in the steering system versus conventional directional tool? Geosteering, going by the coordinates, hitting the targets, makes a big difference, but it becomes important that we have that very accurate and that it helps. Then we look at the number of frac stations and the cost to the well to the frac stage, and what they want to do is lower the cost of the frac stage but have a lot more frac stations. So they want to get very long lines. Here we can see where they set the base station, kicked off to the penetration point, probably had a first take, and then they go these lengths. So this shows 2 examples. If this is inside that area, they didn't have a really good spacing, but you can look at the number of stages that they had, and then you can look at the spacing of the stages, and then how clean they were, how well they were, and how they worked. Then we go over to the production that they had in these 2 wells, and we can see that the well for the first well and the well in the second well, better in the second production. Maybe they had a cleaner drill, did a better top, they had some downtime for some frac offsets, but then you look at their entire well schedule, or what's called their well hopper, or their front end loading, and this is where they're scheduling everything. And if you clicked on each one of these, it would go into a bigger detail for each piece that they have. So that's built into their well schedule, and this gives you an example. So here you can see in this unit they're going to drill this area in the areas that they have the frac in that area. Here's another look at a lot of their frac stations, and it shows a really good detail showing the areas where they're fracking and they're developing. Full coverage of facts through the whole area with the design that they have, trying to mass produce that area from that scenario. So I'll have this posted, you can go through and look at this, but the next thing you want to really look at is where did they drill. And if you go into the Railroad Commission and you start looking at the wells again, you can get into here and you can look at one of your wells, and you can actually go in and look at the as drilled location. The as drilled plat that you get will tell you where they actually drilled from. And I'll pull in the as drilled plat of the one I did last. In my as drilled plat, I'm going to show where the true location of the base station is, where we actually penetrated, and then you can see all my frac stations. And I have some big areas with no frac stations, then some frac stations, and then in. So what happened here? Really good tight frac station, but it looks like what happened, we got out of formation. Might have got back into formation, back out of formation, so we were porpoising up and down from that scenario, and then finally we might have got up out of formation again and then just call it quits. Well, this is one of my first ones into this area, so our drillers were learning, everybody was learning from that scenario. My future drill that I had down here, you could see better drilling as we went through. A lot of new information came our way, and then we started representing. But the geosteering from that element, I'll have some information on that, was there and very important. So look for that, try to understand those elements, look at this geosteering portion, and look at the as drilled. I'll have more details on that, and we'll work on that for one of our final projects here that we'll want to wrap up and deliver in our project 3. All right, good luck.